welcome to your weekly news and community spotlight from Unreal Engine. First things first, the results of the 2019 Rookie Awards are in. Of the thousands of projects submitted, all three Game of the Year winners in console and PC games, mobile games, and immersive media, as well as the Rookie of the Year winner in game design and development, were created in Unreal Engine. We'd love to offer up a huge congratulations to the winning teams behind Spire, Exploro, and Soundbender, Juros, Rodionovas, and to all of the students that submitted their incredible projects this year. Moving to our own contest, we'd like to say thanks to all who participated in the Cinematic Summer event. We loved watching all the submissions. AFO Studio James Field and Chatamaika will each receive a custom Unreal Engine branded chair as part of our DX Racer sponsored sweepstakes. Check out our blog for a few of our staff picks. During the Unreal Engine user group at SIGGRAPH 2019, we revealed a collaborative project with Lux Machina, Magnopus, Profile Studios, Quixel, ARRI, and cinematographer Matt Workman, which put our latest virtual production tools on display and demonstrated how this rapidly evolving technology is radically changing the way films are being made. In our blog, learn more about how dynamic LED sets, paired with modern techniques, are being used to transform film stages into living, breathing worlds. Extended footage will be coming soon, and you can try out all of this tech for yourself in the latest Unreal Engine preview. Earlier this week, we announced a new update for Twinmotion, the easy-to-use real-time architectural visualization solution. With this release, you can get from SketchUp Pro to VR in just 2 clicks. Plus, there's a great new pack of high-quality grasses for more convincing lawns and landscapes. You can download Twinmotion for free through November. When IGN said that Assetto Corsa Competizione offers the best sim racing experience on the market in terms of feeling, immersion, and handling, we knew we had to catch up with the team from Kuno Simulazione. The developers explained how they were able to produce one of the most authentic racing sims ever created, elaborate on how they've achieved stunning, best-in-class visuals, and delve into how they designed a dynamic weather system that not only looks great, but realistically affects how cars drive. Korean studio Action Square took a risk developing Gigantic X, their top-down sci-fi space shooter, a genre and theme typically not popular in the Korean market. It was a risk that paid off, however, as Gigantic X launched with success in both Australia and Singapore earlier this year. The secret? The team found that if they combined the arcade action of console shooters with the mobile platform, they could reach an audience larger than ever before. Now available in 150 countries, read more about how Unreal helped them bring Gigantic X to the global playing field. Leading up to the launch of Ace Combat 7, it had been 12 years since the release of the last mainline game in the series. Not only is Ace Combat 7 the first installment in the franchise to use Unreal Engine, but it also marks the series' first foray into modern consoles. To see how Bandai Namco Studios was able to reignite the success of Ace Combat, we interviewed Katsutoki Kono. The Ace Combat producer elaborates on the great lengths that went into getting the jets to feel authentic, the gameplay thrilling, and discusses how the studio achieved arguably the best graphics for a combat flight game to date. Plus, Kono also expounds on the implementation of Ace Combat 7's critically praised VR mode, another first for the series. We are pleased to announce the opening of our newest studio located in Cologne, Germany. Led by the founders of Factor 5, creators of the Turrican and Star Wars Rogue Squadron franchises, Epic Games Cologne is joined by F5's principal members and serves as part of the company's expanding focus on emerging forms of interactive media. We'd like to welcome them to the team and remind you that we have over 200 positions open across the globe, including new roles in Cologne. Now for our weekly Karma earners, we'd like to give a shout out to Clockwork Ocean, Don Busso, Shadow River, MCX292, Jazz Central, Kevin Ottawa, Leo Miranda 5281, Rolf Sun, Lon, and 6R0M. Thanks so much for helping out folks on AnswerHub. Now on to our weekly spotlights. This slightly haunting scene from Sesha Grenda called Overgrown, inspired by Andreas Roca, is our first spotlight this week. You can see a breakdown of their progress from blocking to final renders, which is a nice way to see how the project like this unfolds. Great work, and we hope you'll share more with us in the future. Here we have Grimstar, an action-packed space combat simulator with action RPG and fleet management twists. Command the last fleet of mankind while you defend the stranded remnants of the human race with your fully modular fighter, growing your forces along the way with the hope of eventually taking down the planet-devouring behemoth, the Grimstar. Last up here is Ashes of Oahu, an open-world post-apocalyptic RPG shooter where you tap into the power of the spirit world to liberate the Hawaiian island of Oahu from the army that occupies it. It's always exciting to see what a small team, in this case 5 folks, can accomplish. Thanks for tuning in to this week's News and Community Spotlight.
Hey everyone, and welcome to the Unreal Engine livestream. I'm your host, Victor Broden, and we're here today to talk about some of our feature highlights that we are going to be releasing now in 4.23. To help me with this endeavor, I have Engineering Director for Graphics, Marcus Wassmer, as well as Lead Physics Programmer, Michael Lentine. And thankfully, these are some of the 2 smartest minds on these topics, so I'm very happy that you were able to come here with me in the studio and do the live stream. Michael, this is the first time that you are on the stream here with us, so I would like to ask you what you do here at Epic and explain to our viewers a little bit about your work.
Sure. My name is Michael. I lead the physics team kind of here at Epic. The physics team is largely responsible for pretty much all physics in the engine. Our focus for the last while has been on destruction technology and the chaos physics system, and trying to get that ready so that everybody can start playing with it.
That's great. Yeah, we have definitely been showing off some cool footage of the demo we did at GDC and now also over at SIGGRAPH. And Marcus, you are the director for our graphics team here, right?
I am. So kind of what that means is I kind of oversee our 4 different rendering teams, as well as the mobile team, the console team, and the Niagara next-gen VFX system team.
Which we are going to talk about a little briefly in just a bit.
Which we will talk about. There's some cool stuff in 4.23.
Michael, would you like to give us a rundown of some of the features that will be coming out with 4.23?
Sure. So from the physics side, this is going to be our first sort of official release of the chaos physics system, which a large emphasis on destruction technology. So there's a number of different features that we incorporated into the system. The first is sort of the notion of trying to basically have this many movable bodies kind of in a scene. So for the demo that we came up with, there were hundreds of thousands of bodies all moving simultaneously. Traditionally, this would have been fairly infeasible with the existing destruction systems, or really just with that many bodies kind of moving in general. So we had to introduce a new component type inside the engine, which we call geometry collections. Geometry collections are a way to group all these bodies together but they can all still move independently based on the rigid transforms that the destruction system will update them with as the simulation progresses. We also obviously support a large number of features for breaking up bodies so that you can take a building, break it up into potentially hundreds of thousands of pieces, or however many pieces you want to break up on, depending on how much computational power is available. And we did this by adding a new mode inside the editor, which gives a number of different controls for how these things break up, different fracture patterns, things like that, as well as the idea of destructible levels, or what we have somewhat colloquially referred to as destructible LODs. So this allows an artist to go in and author a fracture setup that can scale from a small number of bodies on certain platforms to a very large number of bodies on other platforms with a single authored setup. And that was a big focus for this entire system in general, is we wanted to give as much power as possible to our artists and game designers so that they could come up with the most cool and amazing ways to incorporate destruction into their technology. And so a couple different other controls that we provided, potentially the biggest one is the field system. So the field system is essentially a region of space that can set various physics parameters. You can use it to set the strength that a building needs to exceed in order to break up with, so we call it the strain. You can use it to set things like more traditional physics parameters like friction or coefficient of restitution or anything like that. And it just gives a way to control essentially simulations of this scale. So you don't have to go through and say select an individual body and set a whole bunch of properties on that, or have everything tied to materials. We incorporated a number of other systems into the 423 release to try to help with the way that destruction feeds into it. So we believe that physics is something that's potentially underutilized, and we want to make it more of the forefront of trying to make games and interactive worlds, and using a heavy amount of physics systems. And a lot of that requires integration with other aspects of the engine. So I mentioned Niagara a little bit. One of the things that we introduced in 423 is the Niagara chaos physics integration. So this allows you to do things like spawn dust effects or smoke effects when a building starts breaking up. Without this, obviously you get simulations that don't look very realistic. So this is a key feature in order to drive sort of a holistic destruction system. We've also incorporated into other aspects such as audio to allow you to basically create the most immersive destructible environment that you possibly can. And finally, we've added a whole bunch of sort of features for programmatically controlling various things like how a building breaks up over time. And this again has to do with the scalability of these types of systems. We really want people to be able to run simulations if enough computational power is available of hundreds of thousands of objects. And so this means sort of different paradigms in terms of authoring. One of those is what we call the connection graph, so that if you start breaking connections, which happens when some force or some field violates essentially the allowable strain inside the connection, certain parts of the building break off. And if you do this across, say, an entire section of the building, the entire top would, say, start falling and colliding with everything else, which gives you a much more sort of organic, interactive looking simulation. Of course, if you don't want this, you can also add controls to make it more artistically directed. And then the other aspect of this is cache playback. So as we're aware, you can't always have the computational power necessary to run 100,000 objects, but in some cases, you may not need interactions. And so what this allows you to do is do something like you used to be able to do in the engine, or still are able to do, which is bake out something like Houdini, import it in. Of course, this creates a number of problems with iteration time, having to go back and forth between packages. So we now allow you to do this basically directly within the chaos system, within the engine. So you can set up your simulation at 50 frames per second, record that out, and then play it back at runtime. And we also allowed fields to start activating bodies when they interact with those bodies, which allows you to, even if a building is sort of interacting with characters, you can effectively only simulate the bodies that are doing those interactions and allow the rest of the bodies to keep doing playback. And so this is sort of a high-level overview of some of the features that we provided related to destruction and chaos in 423.
Yeah, and we'll be providing an example project as well, where some of the things that Michael just mentioned will be there, broken down, commented, so that you can dig into them and figure out how to work with it. I was a little curious about the fields that you mentioned. Are they similar in any way to the physics volumes that we've had in Engine for a while?
They're a lot more comprehensive. Yeah, I mean, they're really kind of a different thing. This is primarily meant for control of essentially any arbitrary parameter kind of within the physics system. And so it's a really powerful way that artists can use to control kind of everything. We envision this sort of long-term being able to apply to much more than just physics. Right now, it's kind of limited to chaos objects and Niagara particles in terms of kind of what things they can affect. But we expect this to really grow and allow people to have a different way of controlling things at scale.
Would that mean that you'd be able to do stuff like flip gravity?
Sure, you could absolutely do that with a field system. That's basically a physics parameter, and you can set any physics parameter within a field system.
That's awesome. Sharing. Yeah, I know that here in the preview we've had several people go and try out some of the features. Just to let you guys know that all of the ones that Michael are talking about, even though not all of them have been able to use inside the previews, you will be able to use them all once 4.23 comes out. We also wanted to mention that it is a beta release of our new physics engine, and so go ahead, play with it, try it out, check all of the things, and start planning for what you can do in production. The full release will happen in a couple of engine versions. Marcus, there's some pretty cool new features coming, or not new features, but we've done improvements on quite a bit of the ray tracing that we released in 4.22.
Yeah, there's some pretty significant improvements there. One big thing that we did this year was finally release the first beta version of ray tracing in an official UE4 launch. The goal there being, finally let everybody in the world start playing with ray tracing.
Yeah, in real time.
In real time, which is super nice. However, the 4.22 release, was kind of what we considered like the, kind of the basics for what you needed to get started. And since 4.22, we've just been working on kind of stability improvements, performance improvements, and then filling in some of the gaps. So some major things that are in 4.23 is support for landscape for ray tracing, support for instance static meshes and hierarchical instance static meshes. Another really important one is world position offset for skeletal meshes and for landscape. Not for static meshes yet, unfortunately, but at least for skeletal meshes and landscape, world position offset will be properly intersected with your ray tests now. There were a few other like little visual improvements. For example, when you're doing ray trace reflections, you can actually choose in the engine how many bounces your ray should go through before terminating. And in some cases, you really need more bounces than you should be doing if you want to maintain like a reasonable real-time frame rate. So in those cases now in 4.23, we can, at the end of the ray trace, the amount of ray bounces, it can fall back now to one of our static reflection captures, just to fill in something so that you don't end up with like a weird black spot in your reflections or anything like that.
Does that mean that you would set up the scene for both cases? And so using sphere reflection and box reflection captures, baking that as well as...
That's right. And honestly, you would want to do that anyway. Because another thing that you need to pay attention to when you're doing real-time ray tracing, for reflections at least, is that when a reflected ray hits a very rough surface, so that you would get, like not a sharp reflection at all. In fact, most things in the environment are rough/diffuse. So when you hit those things, you can configure the engine to pick a roughness point at which we just terminate rays and fall back to the reflection captures anyway. Because a very rough surface requires a very large number of rays to, properly converge, and that can be a performance hazard that you need to watch out for. So that's something you would be doing anyway in a lot of scenes. Certainly, it's something that we did in the reflections demo 2 years ago.
Okay, yeah, we had Short and Juan Cañada here, and they actually Short set up even a preview mode of how you can see how expensive the bounce would be depending on the roughness value of the material. So if you're interested in that, I'm going to go ahead and drop a link in chat here soon, and you can go ahead and watch that entire, I think, hour and a half of Short going over a big ray tracing example that he's working on.
Cool. So I think those are the big ray tracing features. There's just like a whole host of, probably a couple hundred like small performance and bug fixes and stability issues.
Only a couple hundred.
Yeah, there's, one of the big things that we're doing here is turning like DirectX 12 into a big boy RHI. Like right now, most people default to DX11. With the advent of ray tracing, a lot of people are going to be moving to DX12. So we're spending a lot of time making sure that DX12 is in a good state and production ready and performant competitively with other RHIs as well.
You mentioned RHI. Would you like to dig into what that means a little bit?
Sure. Sorry. So RHI is it's an acronym for Rendering Hardware Interface. So it's just an abstraction layer we have in the engine, so that like high-level rendering programmers that are writing features like SSAO or or depth of field or shadowing techniques or whatever, don't have to write them 20 times, for every single API. So there's this layer in between, and then we have an RHI implementation for like DirectX 11, DirectX 12, Vulkan, the consoles, and any other platforms that need their own specific graphics API implementation.
So it's an important part of making it so it's easier for some programmers to do their job, essentially.
Exactly. Yeah. It's also just easier to maintain the engine if you have a common interface to write graphics effects against, and not have to write something specifically for every platform that we have to support.
So what would the difference between an RHI and sort of the generic term for an API be? Are there any?
The RHI is an API.
Okay.
Yeah. It's just one that we made up as Epic.
Yeah, that's cool. Moving forward, I think we mentioned a little bit about some of the features, and virtual texturing will be another big addition to the engine coming in 4.23, right?
Yes, that is certainly one of the ones I'm more excited about lately. That's something we've been working on for a while, and I'm really excited to see what people will do with it. So virtual texturing, if anyone doesn't know, is a way to do texture streaming, but by only streaming parts of the texture. So let's imagine that you're an artist, or you have an artist on your team, and they want to put like an 8K or a whole bunch of like 8K texture maps on a face, so that when you get the camera, like really, really close, there's still a whole lot of detail in there. And that's, can look really, really good. The problem with a traditional MIP-based texture streamer is, that 8K texture map, depending on its format might be like, 64 megs of memory.
Okay.
And if they layer, 4 or 5 of different of those maps, like your memory footprint becomes enormous, because when you get really, really close to a surface, to get the detail of that 8K map, we have to actually stream in the whole 8K map. Virtual texturing is a little bit different in that we kind of break those very large textures up into like 128 by 128 texture tiles. And instead of streaming the whole texture, we stream just the parts of the texture that you actually need that are actually visible on the screen. So if you would get really, really close to that face again, a lot of that 8K texture is, probably parts of the face that you're not seeing, and we only stream in the bits that you can see. And that means for you can have very high resolution textures, but your active runtime memory footprint is more determined by your screen resolution, more so than the resolution of the textures. So it's more about, the visual fidelity of what you can see and not what you can't. So it's really good for artists that really want to ship that high quality content, but not pay for it, all of the time. It's really exciting. The other thing that I think is going to really unlock a lot of power with virtual texturing is we're also shipping a thing that we're calling, I think, dynamic runtime virtual texturing. So this is a case where we don't actually have any data on the disk. Like, we don't have 8K or 16K textures on the disk. What we're doing is procedurally generating that data and then filling in a virtual texture that we can sample on a material. So like the most kind of canonical use case for this is, imagine that you've got a landscape, and imagine that you wanted to put in some crazy number of layers on it, right? You wanted to have 32 layers on your landscape, like really finely, put a lot of detail in and a lot of transition areas and whatever. In the traditional landscape system, you would have to sample all 32 of those textures for every single pixel. Like, the more layers you stack on, the more impractical it gets, from a performance standpoint. With something like runtime virtual texturing, what you could do instead is go, okay, well, I'm looking at this landscape. Which parts of this landscape can I see? Okay, let's imagine that I've mapped, a 16K virtual texture onto it, or some size. It's not really important. And you can fill in those 128 by 128 tiles, the ones that are necessary to draw your landscape, and you can, at one time, kind of render all those 32 layers and their transitions into the tile, write the tile out, and so it's like a caching system.
Okay.
And so then the landscape itself is only doing one texture sample for kind of this runtime pre-cached kind of collapsing of those layers. And you fill in some large number of those every frame, and the performance of your landscape is now a single texture fetch, and you could kind of, I don't want to say arbitrarily have infinity of them or anything, but certainly more than you would be able to do in the traditional type system.
Is it similar to if you took, say, all those 32 textures and pre-blended them and just took that out as one texture? That's what you're drawing?
Yes, you could do something like that offline as well. It's just that
It's a lot more work.
it's a lot
Yeah.
more work, and it's harder to maintain, and you'd end up like with this big bake step that you'd have to.
Right. Every time you make a change, now
Yeah,
there's...
you have to bake the whole thing again. And like changing the ordering of the layers and stuff, it just becomes like a workflow issue. But you're absolutely right. You could do something like that.
Just trying to find a similarity between a workflow that maybe someone has already gone through that
Yeah,
they might...
you could absolutely do that, and you could use the the traditional streaming virtual texture to do that as well. If you ended up with some 16K bake for your landscape texture, the streaming virtual texturing would still be a good way to deal with that content.
And by streaming, it's actually streaming from the hard drive, right?
From the hard drive,
Yeah,
yeah.
not from a cloud server of any kind.
Correct. Yeah.
That's exciting. Another cool thing that I heard that what will allow is that it's really useful for mobile, right? Because you can reduce the memory footprint of all of the textures will be greatly reduced, right?
So that is the desire. As of today in 4.23, the virtual texturing isn't currently supported on mobile,
Okay.
but that is coming in the future. We're actively working on that because we think it's, specifically for landscape, we think it's very important to kind of maintain a consistent workflow and consistent look across platform. But yeah, the hope is that with virtual texturing, yes, you should be able to maintain a more consistent and smaller memory footprint for your textures, and that should be of benefit on mobile as well.
Yeah, because we're limited in memory more so on mobile devices than we are on...
It's a pretty significant limit, especially depending on what kind of what devices you're targeting for your game.
And most developers want to target as big range as
most
possible,
people,
right?
you want to just hit as much stuff as possible for the broadest audience. Yeah.
Yeah, and that can be hard. I definitely had to either split the landscape up to sort of get high fidelity and try to design it in a way that culls section of it, it's just static meshes, and then you lose the functionality of being able to use the landscape tools in the editor as well. So a lot of cool features around that tech.
I guess I should mention like the description of what I mentioned with the landscape layering system is an example that is not shipping in 4.23.
Okay.
But it's something that we are working on.
So
Future stream.
It's coming, like a lot of exciting things. Was there anything else around the ray tracing and virtual texturing that you wanted to?
I think those are the two major those are the major call-outs for those.
Okay. Let's continue then. We are shipping native support for HoloLens 2. It's coming in 4.23. It's in beta, but you'll be able to use it natively in Engine. We also have a couple of virtual production pipeline improvements, and some of this stuff you might have come across on YouTube already or any of our other channels, where at SIGGRAPH, we demonstrated this new kind of way of being able to record or essentially doing CG in real time in the set. And the way we do that is using an LED wall that is almost encompassing sort of a 270 degree stage, essentially. We see if Amanda can go ahead and drop us a link there. I wasn't able to find the right video to present for y'all, but it's on YouTube. It's been showcased in plenty of places.
Yeah,
and
that thing is really cool.
Yeah,
I actually had the opportunity to visit that stage while I was out at SIGGRAPH, and it's very neat. It's very neat. There's, as you mentioned, like the big 270 degree LED wall, like with a ceiling, and UE4 is driving the pixels on the whole wall, so you're like loaded your 3D seed in there. You've got like the actual real camera is being tracked in the space, and that's feeding data directly into the engine. So like to move the rendering camera,
sort of the virtual perspective.
So you get like you get correct parallax and perspective from camera movement onto the from the wall from the actor, and you get you get lighting on the actor and the real props that you have in there that matches like the environment that you want to film them in, which is a huge improvement over like a traditional green screen where you kind of have to redo all the lighting in post and like fix up any like green reflections or whatever. Like the thing that really struck me being on the stage is there was a very shiny Indian motorcycle on the stage, and if you like actually walk up to it and just like look at the bodywork or like look in the mirrors and kind of forget that these walls are around it, it looks like it's really there. And that's a really good improvement for people actually doing film content.
Mm-hmm. Yeah, there's another shot there, I think, when they're close up on the rider, like riding motorcycle, and the screens are sort of doing, the motion, and all those reflections, you can see them in the bike, and that really helps selling the point that like he's actually riding it when he's actually sitting completely still.
Yeah, it's really cool, and it's all like in camera. All of it's live. None of it's like fixed up in post or whatever. It's really cool. It's a really cool piece of tech.
And it helps directors and everyone who sort of is involved with the photography of the set. If they're interested in a change, they can on the spot just change it.
Yeah, the whole thing is live, driven by some people that are kind of operating the editor, kind of off camera. So if your DP or something wants to change some lighting or change the background environment or move a rock or rotate anything, you can just do it right there, right on the spot. Super cool.
And
if I understand correctly, you can also do that within an iPad, correct?
Yes, we are shipping support for, I think it was called like an HTTP protocol that will allow you to build an interface in HTML5 or just any browser and load that on any device because it's just a browser, and you can use that to drive the settings and parameters inside Unreal Engine.
Yeah, we had a prototype of that on the stage there, and it was really cool. You just hand someone the iPad, and they could mess around with the lighting or swap environment backgrounds or move kind of light cards that were in the 3D environment and then projected to the wall to like get some off-screen like extra area lighting on.
Oh, so similar to what like we have here at the set, right?
Yeah, exactly.
We got big strong
It's just
lights.
instead of having to physically move the lights around, you just take the iPad and kind of move them around because the light is on those very bright LED walls. It's like you're moving a real light.
They're very bright.
Yeah,
that even comes through in the footage, although I haven't been there myself. You can see that. Yeah, it's pretty magical. You should all go check out the little.
Check the video out. It's pretty cool.
Yeah. It's definitely. We'll see a lot of that moving forward. We had John Favreau talking about some of the work that he is doing at SIGGRAPH, and huge proponent or supporter of the technology and just what it allows for directors and producers to do on set. So I'm sure moving forward, this is obviously like first of its kind, right? And we've sort of just announced the technology, but slowly but surely, I'm sure it will trickle out among studios and
I expect it's going to be pretty common for television and film production in the next couple of years for sure.
Yeah, if you're curious about sort of how people have solved the problem between lighting on set versus what we're actually rendering behind of them, we did a showcase for Welcome to Marwen, which was actually a really cool example of how they were able to do that previously using a green screen, and even though they solved it in a very, very interesting fashion, and they were able to get almost final imagery from the set. For me, it's just interesting to go back and see like what we had to deal with, and now what technology is bringing to the table and allows us to do without having to go through some of those.
Yeah, you should see people that go and see this thing, their eyes light up. People that make
their eyes and their faces.
Yeah, they have a ton of fun on the set. It's pretty great to see.
Yeah, it's exciting. I'm hoping I get to see it at some point soon. What else? There's quite a couple. I've been pushing a lot of fixes to on the forums that we're providing for 423. I'm not even sure what the change list is, but it's a big release in general. I mean, especially real-time ray tracing coming to a point where it's more usable in production. You did see one of our spotlights earlier, right after the news. It's actually from Grimstar, and they've implemented RTX in the entire game. Mm-hmm. Which it's like it's right there.
Yeah, it's available now for anyone to integrate into their game if they would like to, and also we've been using it internally as well, not on games, but like for Fortnite trailers and cinematics and things. Our cinematics team has been trying ray tracing out too, and they've been really enjoying it.
Yeah, it's just always RTX on, RTX off. Seeing the difference it's cool, and it's neat that you can do that did it all in real time. Some other topics, I want to mention that for both Chaos next week, we are actually having Wes Bunn as well as Jack Oakman here to walk everyone through how you can set Chaos up, because currently you are required to use a source build of the engine. Until Chaos comes out of beta, that will be the case. And so if you're unfamiliar with how to compile engine from source, we're going to touch a little bit briefly on that and then walk you through how to use some of the topics that Michael mentioned earlier, of how you can actually use the system. And then I believe I have something scheduled for virtual production as well in the next coming months. We are also shipping a new performance, or should we say profiler, would be more accurate.
This is one of my favorite features of 423. I'm really excited about this thing. So it's called Unreal Insights. It's something our core team has been working on for quite a while. So Unreal Insights is a new CPU and GPU sampling timeline profiler. It's great. So you can capture massive amounts of data from your game. If you're familiar with our existing stat system, it's essentially capturing all of our stat system, as much of it as you want to turn on, as well as GPU events. And I'm not sure if this is in 423, but it's planned to also put like I/O events in there as well. And it's written so it can handle massive amounts of data, because we kind of battle test the thing on large projects like Fortnite. And so you're capturing all this data, and you can zoom in and out and display all the performance data very well on a single timeline. On a single timeline, you can see all the different CPU threads, what's going on in the GPU. If not now, soon, what's going on the I/O thread. And it really gives you like a good way to analyze the performance of your game and find out, where are you getting hitches from, why aren't you making frame rate, what systems do you need to look at. It's really like, well, it's a dream for me. I'm very excited about this tool.
Rather than hopping between the GPU profiler and...
Exactly. Having it all in one place, so you can, sometimes you need to know the interaction between systems. Like sometimes the GPU frame is slow because the CPU is slow. Like if you're not feeding the GPU fast enough, then the GPU goes idle. And that's something that's kind of hard to see from a lot of GPU timers. But if you've got the GPU timeline there combined with the CPU timeline, you can see, oh, there was a 100 millisecond CPU frame, and then the GPU was slow. And you could just kind of connect those two dots really easily when it's all combined in a single timeline.
It's great. It's also coming out in beta in 423, and we are, I think, in 2 weeks, I actually have a live stream with some of the subject matter experts on Unreal Insights, and we'll walk you through how to use it, which will be exciting. And that will be a learning lesson for me, because profiling and figuring out where your bottlenecks are can take up quite a bit of time, and also sometimes cause you to make pretty big changes in the way that you are implementing new features or your asset pipeline. And being able to figure that out a little easier, I think everyone will be very happy. Some other topics that we can mention just briefly. Obviously, the release notes will eventually make it out, but this is sort of a little preview for all of those of you who are excited. We got a new end-display warp and blend for curved surfaces. I believe this is an improvement to our current end-display tech.
That's right. So, I think in 422 we shipped the first version, or maybe it was 21. I don't remember exactly. But it's for something like square LED walls where you need to do projection from multiple machines to sync things up. So with the warp and blend, it's more for like curved surfaces or different physical installations that you might be building. Think like a planetarium dome or something like that you need to project some content onto that looks correct, and it's handy for that sort of thing.
If you're curious what that might look like, we also did a showcase on the Childish Gambino concert and how they were using that technology to do just that. It was a dome, and the stage was in the center, and the audience was just all around. And this is almost, it wasn't interactive, but it could be. If you were able to give everyone, I don't know, some kind of hand tracking, and they can control things on the ceiling, that would be really cool. Moving onward, Niagara improvements. Niagara is still in beta, but there's a lot of work being done there.
Yeah, there's been some pretty significant improvements in Niagara. It's definitely one of my favorite new systems that we have. It's been around for a little while, but it's getting really, really, really good. This is something that's kind of allowing our tech artists to have, as much freedom as, you just imagine when our artists first got the material graph, and they could any artist could make their own shaders. Well, now it's like any artist can make their own, any tech artist or developer can make their own, high performance, data driven, data manipulation, simulation, in a graph interface. It's really cool. And so for 423, like some of the cooler things, you can now sample static and skinned meshes in a GPU particle system. This is something that we did on the troll demo that we did for GDC, where we had, if anybody saw it, we had like these kind of fairy type creatures that would move around that were skeletal meshes, and we spawned something like 600,000 particles a second from the surface of their skeletal mesh, so it looked like they were, kind of made of fire. When you're sampling from the mesh, you get something like you get the position, you get the UV, and you can use that to sample textures and kind of manipulate what you're spawning across the surface of the meshes, and it's on the GPU, so you can do lots of them, and because they're skeletal meshes, it means you can very easily track things that are animating. So you can do any sort of animation and do all sorts of crazy particle effects and stuff. It's
So
really cool.
in terms of the troll demo there, where the fairies were sort of flying and lifting the crown and moving,
That's right.
that was an actual animation that was being played back, and
Correct.
right, and then Niagara was actually handling, basically rendering.
Yeah, Niagara was dynamically running and simulating the particles, based on the positions of those animations. Yeah, none of the particle was pre-baked. That was all kind of run live in Niagara.
You said 6,000?
600,000
600,000
per second spawned. Yeah,
That's a ridiculous number.
it was pretty cool looking. It was,
Yeah.
Yeah.
That's
Some other cool things there. Definitely the integration with Chaos that Michael mentioned earlier, so that instead of having to somehow pre-calculate where all your impact effects and stuff from destruction events would go off, you can just get that data directly from the Chaos simulation, and however it simulates, you can get your dust effects and explosion effects in the right place. It's really important to selling those things.
Can you, so Michael, question for you then, is it that would make it entirely possible to sort of do the cache simulations and then tie Niagara to that, right?
Yes, so this works through a form of event system, and as part of the caching simulations, if you use sort of the cache from Chaos inside the engine, it will also cache those events. And then when you play it back, you can essentially play back those events, which will then trigger Niagara simulations if you're set up to listen for them.
Is there similar to some kind of a timeline there that you work on, of being able to sort of notify when those are supposed to be spawned?
So they happen when the simulation kind of says they happen.
Okay.
The playback can happen a number of different ways. The most common one, which is what we used for the demos that we showed, it's also kind of what we have for the content that we're going to release, is essentially set up through Sequencer. So what you can do is you can use essentially Sequencer to play it back, which gives you some amount of control over kind of how you're playing things back. And then essentially when those events happen through the Sequencer playback, it'll trigger whatever event you have hooked up.
Well, let's see. I'm not sure. You dropped a little bit there, but I think your sentence ended, and I'm good to continue. Yes. Before we move on, I'd like to go through some of the questions that we've received
Sure.
on the topics already. Let's see. Just gonna take a quick second to see here. So they're asking Chaos, when is it fully available for production?
Not right now is the short answer. So it's certainly our first release, and there's going to be a lot of rough edges. We're excited to see what people can kind of figure it out, but it is definitely a risk to try to ship out anything with it. All we've effectively shipped with it internally is demos and content and things like that. So we have not shipped a full game with it internally as of this point. So there will be issues that certainly come up that way. We expect over the next couple of releases to ship Chaos kind of in its entirety out of sort of beta. But as with kind of everything, timelines are a little bit nebulous. But we are working sort of very hard, and really believe that Chaos and physics in general is going to be a large cornerstone for the future of the engine, creating interactive worlds that kind of everybody can play with. And so basically our entire focus is to try to make that happen.
Yeah, and even then, being able to touch touch on the tools and play with them and see what they're able to do is important of sort of any pre-production, no matter if you've used the tools before or they're brand new. And so being able to start using them and planning what you might be able to do in the future is as important, going through that process as it is actually producing the content itself. And so I hope everyone's excited to get to play with it. I mean, almost everyone loves things breaking, right? It's a little difficult to not smile and be happy when you see big blocks of things exploding. And it's all virtual, so no harm is done. A lot better than some of the other ways that you can do that. Let's see. On the topic of virtual textures, is there a quick way to measure the performance aspect of traditional streaming versus virtual texturing?
It depends on what exact type of performance you're trying to measure. So if you're sampling a virtual texture, there is a performance cost compared to sampling a regular texture. Because the way virtual texturing works, you're basically doing 2 texture fetches because you have to fetch to a smaller kind of like indirection texture that tells you where the smaller tile is in a larger physical texture. I don't really need to go into it, but so for measuring that overhead, I would recommend doing something like taking one of your materials that you're worried about the performance of, putting it on a card and like making it fill the screen, and then maybe have like a static switch where you can turn on and off, like going down a virtual texturing path versus like a traditional texturing path, and you can kind of A/B there on your target platform. Filling the screen is just a good way to like make sure you get the maximum. Like, what is the worst case of this one material filling every possible pixel that I have to shade? If you're talking about the I/O performance, it's really going to depend on your content and like what kinds of textures you're wanting to stream. I'm trying to think of a good way to.
Do you want to explain what I/O is and what it means?
I/O is like input-output, like streaming speed off of the disk,
Okay.
basically, like from disk to hard drive. Because part of the problem with the old streamer is like you're really streaming in a lot of data that you don't need. But it does have some positives in that it makes a prediction of what you're going to need and can kind of start sooner. It might be bringing in too much data, but it's bringing it in sooner. Whereas virtual texturing works based off of exact GPU feedback of exactly what the GPU wanted. So it's always kind of a like a just too late system. Like one frame, the GPU requests this thing, and you go, oh man, I need this tile. Time to read it off the disk. It streams tiles very quickly, so usually you don't really notice that too much, particularly if a fair amount of it's already kind of in memory and the actual visual change isn't too much. But it's a tricky thing to like really A/B. I think you really need to pick which metric you're trying to understand you're measuring and then set up a test case for it.
Okay. I did see one quick example of just enabling streaming virtual texturing, and it will show, so when you're inside the texture editor or viewer in the engine, you turn on virtual texturing, and you can actually see the reduce in memory footprint that the texture will have when it's loaded. And so that will give you an idea.
That'll give you an idea of the memory footprint changes, yes, but not like runtime performance or streaming performance.
Of the cost of doing those,
Right.
that itself. Let's see. So this is another question for you, Michael. Are you going to support soft bodies and fluid simulations in the future?
So at some point in the future, I would say yes, but it's, our focus is really to sort of build the foundation, get sort of chaos in its current form, kind of production ready and up and running so that it can be used for anything. But, kind of as I mentioned before, our focus is really on a large scale, trying to make worlds more interactive and dynamic. And so pretty much everything sort of physics related sort of falls under that scope, including soft bodies and fluids.
See. Another question regarding chaos. Will mesh tessellation and chaos play well together?
So they certainly can play well. So mesh tessellation is independent of kind of the destructible LOD system that we've talked about. You can, at any one of those kind of levels, add mesh tessellation kind of on top of it. So you can kind of do it to the extent that you want to do it, but they're sort of separate systems. So you're not going to have automatic mesh tessellation based on destructibilities or something like that. You'll have to set it up on that particular level for that particular mesh. And if you want it on, say, all levels, then you have to set it up for all levels.
And I'm assuming, just like normal, that the collision of the simulated meshes will not be able to take tessellation into account, right? There's still some form of primitive?
Yes, so collision, so we have a number of different types that can be used for collision inside of chaos, but yes, mesh tessellation will not affect that at all. Currently, our primary collision types are spheres and boxes and level sets, and that will be expanded over time.
Let's see. A question for you, Marcus. What the 4 rendering teams here at Epic are, and what their main focuses are?
Sure, I thought I might get that question. So we have there's a ray tracing team. There is an RHI team, like I described the RHIs earlier, because we need people to actually implement all those different APIs. And then the rendering team right now is one of our more distributed teams at Epic. So we, for lack of a better name, we have like a features team east and a features team west. And the team don't always fall within those buckets, but that's just kind of a moniker where most people in the East team are kind of, here in North Carolina or in like Stockholm or UK or something, and most people, on the West team are in our San Francisco office or Vancouver or I feel like I'm forgetting someone, but there's also some people in like Korea as well that just like fall under.
So it's sort of
things.
east and west from the center of the
like from
North
the center of the
America,
U.S. Like it's just as a way to kind of break it up so that we don't have like one giant 15-man team or 20-man team.
Let's see. We're curious. How about custom shaders for ray tracing? For example, colorize ray depend on incident angle.
So we don't have custom shaders for ray tracing just yet, at least not in like the material graph where you could like say choose to make a closest hit shader or something like that that's custom. If you are in a position where you can like write plugins or modify the engine code, you can create your own custom like ray generation shaders as like a global shader plugin. Or you can, if you modify the engine, you can write the other ray tracing shader types as well. It's just not something that we've really exposed yet to the high level. It's something we're thinking about doing and probably will do in the future. It's just we're kind of laying the foundations here for what good ray tracing support looks like out of the box, and then at some point we'll go, okay, like we've done, most of the basics, and then start to open up the toy box to tech artists and stuff.
We gather all the ingredients, and now it's time to add some spices, essentially, would be the metaphor that I would use. And then there's another question here, if there will be any live streams dedicated to virtual texturing, and yes, there will be. I'm currently planning one on the 19th. Hopefully that will come through, and then we'll walk you through as much as we can. Let's see, does ray tracing work with Vulkan?
Ray tracing does not currently work with Vulkan right now. So currently we only support DXR. Support for Vulkan is planned eventually. Basically when Vulkan has, if and when Vulkan has an official ray tracing specification, then we will work to support that. Yeah.
Let's see. Does virtual texturing also affect light maps rendered with light mass?
It can, yes. I would, I guess, want to double check that it's still in 423, but I believe that the option to have virtual textured light maps is still there. Kind of the only thing with that is, yes, you can use virtual texturing to lower your light map footprint, and you can, theoretically increase the size and resolution of your light maps much more easily. It's just, of course, the larger you make your light maps, the more bake time you're going to grab. So, like the idea of maybe I make a 16K light maps everywhere, you could do. You just might end up waiting a while to bake those things.
let's see, virtual texturing. Does that mean we can now have 64K plus textures in Unreal?
So right now you can't. That's actually something we went and tested. So support for that is planned. It's just that in testing, I think after we got over 16K or 32K,
Okay.
there were some bugs that started to show up in various places where, there was some places that were using int32s that needed to be a little bit, bigger size and whatnot. So for the moment, I think 16K is the safe bet. We will be kind of fixing those paths and making it possible to have bigger textures in the future.
That would be a very high-res face that you
Very
would be
high
able
res
to,
space.
yeah.
Or like Google image search data. Like there are uses for this stuff that aren't just like a super high quality character.
Let's see. They're asking RHI on multi-GPU.
RHI on multi-GPU. So
Let's see, there were some follow-up questions that might help. Non-SLI mode, option to select GPU for rendering.
so here's a state of multi-GPU in the engine. We have RHI support for it, which means you can write high-level rendering code that can, at least for DirectX 12, and we only support this on DirectX 12. You can write rendering command lists and choose which GPU they're going to render on. There's primitives for transferring data between GPUs, and there's so there's synchronization, command list, and then there's like resource control of where resources live. So if you were willing to, modify the engine, you could customize the renderer for your workload to move certain work off to other GPUs and bring it back. At the moment, we don't have like a turnkey solution. Like if you just plop another GPU in there, it's really not going to do anything out of the box. And the reason is we found over the course of the last 2 years of doing like the Reflections demo and the Porsche Speed of Light demo, and that the workloads for different content are so different that hard coding those paths into the renderer is just not that valuable for anyone. But all the RHI code is there. If you want to write multi-GPU code, you can. It just doesn't come out of the box. As far as the second question for GPU selection, 99% sure there is a command line option to choose a particular GPU to use, for the instance of the engine that you're launching. If that person would, I don't know,
Yeah,
probably
a little curious
answer it
for
on
you.
Answer Hub or something, make a post. It's in the, I think if you look in the device creation code in like DX12 device.cpp, you can see it there if you look for it.
Okay. See, support for volumetric gobo lights in light function material.
Yeah, that's a request we get sometimes. The problem with those kind of lights is that kind of our fogging solution, which is mainly like the Froxel fog that we have, is a fairly low resolution type effect because it was mainly built for like environmental fog and stuff. And you can kind of use it for those kind of lights, but the resolution is really low. And if you crank that up so that it looks good, which you can do, it kind of raises your hardware bar because it gets pretty expensive at that point. So there's nothing extra planned right now for light functions for those things, but we do plan on improving our volumetric support overall next year.
Is Froxel a fog voxel?
No, Froxel is a frustum voxel. So,
Okay.
Sorry if you imagine your graphics programmer here, but if you imagine your like trapezoidal-looking camera frustum, like little boxes of varying sizes that kind of cover the frustum and they get bigger in the back, and you can, each one of those had some information about the fogging system, and kind of the smaller those boxes get, the better the resolution you have, and the more fine-grained of an effect you can have with that system.
I learned a new word today.
Yeah.
But
And that's the existing like volumetric fog system that's in the engine. That's just how it's implemented.
Let's see. Does the streaming textures get MIPed to?
Sorry, say that again?
Does the streaming textures get MIPed to? I think they're asking if streaming textures are MIPed.
I'm assuming the question is for virtual texturing, and the answer is yes, it has MIPS. I think they only go down to the tile size, which is like 128 by 128. Don't 100% quote me on that though, but we will have a technical spec. But I'm pretty sure the MIPS go down to the tile size of the virtual texture.
Okay. Another question for you, Michael. Is chaos only meant for destruction, or is it a full replacement of the physics engine?
So in its form in 423, it's pretty much a destruction-only system. There is sort of early support for general kind of rigid biodynamics, but there are a number of features that are kind of still absent. We are actually working on sort of filling those people in and filling those features in, and it will be more of a full-fledged system in future releases.
Let's move forward one step at a time, right?
Yes.
Let's see. Question you might be able to answer, Marcus. How are things progressing with support for USD? And for those of you who don't know, USD is a new file format.
Yeah, I'm not keeping up 100% with the USD support, but it is progressing. Like we do have people like actively working on it. Although I couldn't personally tell you exactly what state it's in. It works. Like you can import USD things. There just may be some features that don't quite work yet. Like for example, I think you can put material X definitions into USD or MDL definitions or something like that. I'm not sure that we import those yet.
Yeah,
We might. The tools team would know if you get Matt K on here on a live stream or something. He should
Matt
be able
K?
to answer that.
I'll write that down, see if I can tell him that. Marcus told me that you should come and talk about this. Let's see. They're a little bit curious about chaos and networking, and I assume they mean network games.
Yeah, so there isn't a special solution for networking with chaos right now. It pretty much piggybacks off the existing kind of network solutions. Things like destruction at scale, if it's dynamic, there are potential bandwidth problems that you're going to currently run into if you're trying to do too much. If you're doing a limited amount, that should work more smoothly, but it is something that falls under the category of things that are actively being worked on to come up with a more efficient solution for large-scale destruction when there are bandwidth limitations.
So it's pretty much you get to the same problem or limitation where we can't have the server tell all the clients so the server runs the simulation, then the server would have to send a huge amount of data of where each and every little simulated piece goes, right?
Right.
And that would still cause just a fundamental bandwidth issue, right? That there's just a lot of data that needs to be transferred.
Yeah, you're probably,
Yeah, I mean,
if it's not
we have
gameplay affecting, you're probably better off just running the simulation locally, right?
Yes, that's why. Yeah, that's correct. We have a number of ideas and things that we're currently experimenting with, so I would expect improvements in future releases. But yeah, in its current state is pretty much what you described, unfortunately.
Let's see. They're also a little curious when Niagara will make it out of beta.
So we are trying hard to make sure that before we take it out of beta and say it's production ready, that we've actually battle tested it hard. The short answer to the question is either late this year or early next year is when we expect it to come out of beta. And to do that, we're kind of dog-fooding it internally on a very large project.
And if you're unfamiliar with the term dog fooding, there's a little anecdote of where that term comes from. I believe it was a CEO of a dog food company that would actually eat the dog food.
Oh, okay.
Maybe you don't.
Okay, so that's a grosser anecdote than I thought that it was. Yeah, but.
Sorry, I apologize if that. But and that's as far as I know, it's what I've been told. That's where the term comes from. That he was dog fooding. I'm not sure if he had his employees eat them as well. I hope not.
I don't know.
He was eating the dog food to make sure that it was okay for his pets.
That said, like Niagara in its current state, like in 423, we think is pretty stable and pretty feature rich. So I encourage people to try it out and let us have any feedback because we're kind of coming into the last stages of bringing it out of beta.
Yeah, I saw a really cool tweet from one of my friends. He's doing windshield wipers, Just it was like essentially in the particle system, he was making it look like there were two windshield wipers brushing all of the rain away that was coming down on the windshield. So and that's essentially, it's not only a better looking system or more performance, it's also the actual tools of making particles that have been greatly improved over something like Cascade.
Yeah, it's a huge improvement over Cascade, and we try very hard to make sure that things are rock solid before we take the beta tag off and tell people, yes, this stuff is ready to go. Ship your games with us, and often we do that by shipping our own games with the thing.
Let's see. I'm so into this discussion because I'm really happy to be able to ask you all these questions to get amazing answers that I don't really have time to read the questions. So there's a little bit of general questions, just some of our other features. Did we get RTX landscapes or improvements to GI for RTC?
You did get support for landscape in ray tracing. There was some improvements to ray trace GI, although I wouldn't say it's production ready or like super performant yet, but there were improvements made. I'm not familiar with RTC.
Me neither.
I don't think I know that acronym.
Plans for full Vulkan support for PC?
Yeah. So, we do ship Vulkan on Android for a few devices on Fortnite, and we're intending to make it our primary RHI on Linux for like Linux desktop rendering. And so that kind of coincides with, PC Vulkan. It's, I don't know how I want to say, like we haven't shipped something with it, but it's in a pretty reasonable state. Like if you were someone that wanted to ship on, a single RHI on a Linux and Windows and mobile game, I think you could do it on Vulkan today in 4.23. Like there are still some minor bugs and a few minor features to do, but I think when we kind of tear the Band-Aid off and make it the default on our like fully remove OpenGL4 and just have Vulkan on Linux, that'll be the day when we kind of say it's definitely good to go for everyone for all purposes.
Would that help you sort of know what your game will look like on other devices when you're iterating on PC as well?
Generally speaking, we try to make sure that things look the same no matter which RHI you're on. As long as you're using the same, one of our three renderers, like we have a deferred renderer and the VR forward renderer and the mobile renderer. If you're using the same renderer, things are going to look the same, no matter which RHI you're using. It's more about your testing matrix.
Okay.
Right. You're not testing DX12 and DX11 and Vulkan, on all these places. Like maybe you're a company that just wants to test just Vulkan, right, to reduce your testing burden and stuff.
And we're wondering if is virtual texturing only for terrains, or can it be used on models and characters? It's for everything, right?
It's for everything. Yeah, it's not just for terrain. You can, for the streaming off disk virtual textures, there's just a new node that you plop into any material you want that can sample a virtual texture, and you can, apply it to anything that you would want to apply a material to. And the system I was talking about, like the decal system on the terrain using the runtime virtual texturing, like generation caching system, is not available yet. It will be soon. But that's just an example of how you might use that system. Like the system we have is pretty generic. So there's just like an API you can hook into to put data into a virtual texture. And it's up to you what you want to use that for. The landscape example is just an easy example to talk about.
Yeah, and probably a place where the benefit of runtime virtual texturing will be the greatest.
Yeah.
Here's the biggest. Let's see, how is the progress coming along with GLTF support?
With GLTF support, I'm not sure. That's maybe one for the Datasmith team.
Okay. And then I think there's another question here that might be for Datasmith. Is V-Ray being fully integrated into 4.23?
So the V-Ray guys do their own implementations. Like, we don't have really anything to do with the development of their plugin. So I'm actually not sure. If there's any information, it should probably be on like the V-Ray website or something.
Okay. Yeah, we'll see if someone can reach out there. Let's see. What is the status of light propagation volumes?
The status is pretty much the status quo. We're not doing active development or improvements to LPVs. So kind of they're in the state they're in. It works for some people. Like it can be a reasonable outdoor GI solution if you don't care too much about the leaking artifacts and you can afford the performance. But we're not doing anything further with them right now.
And then another question for you, Michael. They're curious about perhaps, they'd be nice, asking perhaps a time frame or some insight into vehicle physics changes like wheel colliders.
Yeah, so vehicles is something we don't currently cover with Chaos, and so the solution that we currently have is sort of the physics vehicle system. I'm not currently familiar with kind of their timelines, but we expect to, over time, kind of expand Chaos to also be able to cover vehicle type systems and plan a pretty comprehensive kind of set of controls that can be used to do that, as well as other sort of rigid body dynamics within the new system.
They were curious about support for colored translucent shadows with dynamic light source.
Like in ray tracing context, or
Maybe, not entirely sure. That's not part of the question.
yeah, I often get that question in a ray tracing context, and assuming that's what the question's about, the ray tracing team that's kind of an active area of research. One of the problems specifically with translucency and the real-time ray tracing is that it's kind of a performance hog, because you've got to do ray intersection with a translucent surface. You've got to let the ray go through. You might have to intersect multiple levels of translucency, depending on how the ray reflects against the surface. It's just very complex, and a lot of rays could end up being thrown. And that whole thing is kind of an active area of what can we do and still keep it real time. So that may come in the future, although right now I don't think that you can get good colored, translucent colored shadows right now.
And there are some other things I can see there, because today, if you're trying to do something that simulates real life, we don't have single pane windows anymore, right? There are several pane windows that will technically reflect between each other, and so there's quite a bit there to actually get it looking real. Someone is asking, and I'm not familiar with this acronym, but maybe you are, what about SVOGI for real-time lighting?
Svogi, yeah, we had an implementation of that a while ago. We don't really think it's viable as a tech right now. Svogi has some problems that are kind of fundamental to the technique with light leaking mainly, and kind of the grid of voxelization, making certain like level layouts impractical, or to cause like extreme artifacting if things aren't laid out a particular way. So it's been researched here before. It's not something that we're really pursuing. Although if you're interested, I believe NVIDIA has a fork of the engine with one of their implementations of that you can try out.
See, I think those were all the questions that we would be able to ask here. I'm just gonna make sure that if there's anything else that we like to touch on. Oh, there's a new cool feature coming out for animation blueprints, where you'll be able to take an animation blueprint and essentially encapsulate it within another animation blueprint, which the biggest benefit I see is that you'll actually be able to have several designers working on and checking out, which is essentially unlocking the files when you're working in a source control situation.
Yeah, that, and also just a large complex animation blueprint will become, you can kind of encapsulate little bits of it and make the high level logic flow yeah, a little more understandable, like once you've got something that's sufficiently complex.
Right, you could say something like upper body, right, and divide it into lower
exactly.
body, and just know if something breaks, you can also
Yeah,
divvy it up a little bit
even
easier.
just as an organizational technique, it's a useful feature.
We also have some new sound features, although I'm going to try to get maybe Aaron or Dan on here, and they will talk a little bit more about those, but stay tuned. And then I believe we have this new tool that was CSV to SVG.
Right, CSV to SVG tool. I don't know if we can bring up a little thing, but so there is a feature in the engine called CSV stats, meaning comma separated values. And this is a very lightweight stat system, and it just dumps certain just like key value pair of name stats out to a file very, very quickly with very low runtime overhead. And then this tool, which is CSV to SVG, SVG is like it's just like a little graphical format. And it basically just makes a chart for you over time. So you can do something like, we used this a lot on the Troll demo when we were doing performance runs, every day. We would play the cinematic, dump out, all the stats that we cared about, like, GPU time, CPU time, maybe number of draw calls or whatever it is that you want to chart. And then you run this tool and it just makes like a nice little graph over time for you. And you can just kind of, see where you're spiking and like on which, on the timeline, where you're having a problem. You can use it to track chart memory. It's just a nice visualization tool for your performance data.
Easier way to grasp what's going on.
Yeah, we use it all the time on our cinematics and tracking performance on Fortnite.
I think we might be rounding up on the end of the stream here, actually. We've been touching quite a bit. Is there anything else you would like to mention, Michael? Maybe some thought hit you while we were sitting here?
I think I pretty much covered everything. As I said, we're very excited to see kind of what people are able to do with the existing system. I've caveat again that we don't expect it to be able to be used kind of in a production setting as of this point, but we hope that people can kind of play with it and give us some feedback as we continue development.
Yeah, I've seen a couple of cubes breaking already on Twitter and the forums, and hopefully there will be some more grand destruction coming through our channels in a bit. Definitely excited for it. As always, there's a whole other slew of fixes, improvements, and other various aspects of the engine that we've been working on. Right, we are actually, okay, so another thing that we can point on real quick, which I am also planning a live stream for, because I know I might be getting that question, but it is actually the multi-user editing improvements that are coming to the engine. And this is sort of in lieu, that's the wrong term. It's alongside the VR scouting tools that are coming as part of our virtual production improvements, where I think we touched on it briefly, but directors and sort of people who are responsible for the virtual production set, they can actually together in real time enter their virtual world and together move around, look around, and figure out where should we have the set. They have a virtual camera, and this is all in VR, virtual camera that they can move around in VR and sort of have a very collaborative and much easier to explain, because you can literally point at things in the virtual world and sort of share that experience together. And so I'm definitely hoping that I'll be able to get the subject matter expert on that on the stream here, and maybe we'll be able to set up a way that we can display that for you. That would be a little bit of a hardware, a little bit of a different hardware setup, but maybe we can get a couple of vibes in here and do a live stream in VR. Might be possible. We will definitely see, but we're at least gonna show you off how you can use the tool and all the benefits that comes with it. And then the last point, I think, off of what we're shipping for 23 is disaster recovery, which I'm not actually sure entirely what it's about. So maybe I will just leave that. Maybe
the idea here is that because the way the multi-user system works is it's basically like a little server of the engine that's running, and it's doing kind of transactional recording of what's going on, because if somebody moves a thing, it has to like record somebody move the thing and then send that out to everyone else. So if you already have this separate process that's recording everything that's going on in the editor, then you can have a separate process that's recording everything that's going on in the editor, and then if the editor crashes, well, now you have a record of everything that you did since the last time you saved, and then maybe use that to kind of recreate your data and recover from the crash. I'm not an expert on exactly like how feature complete that is as far as what kinds of things it can recover from, but that's the basic idea.
I believe it's experimental.
Yeah, it is. It is experimental.
Yeah, very first feature. That's really neat, though. I don't know if that was planned or if it just came out.
I think it was like a happy accident. Someone realized, oh,
Yeah.
well, we have this server that's just sitting here recording everything. Why don't we use it to bring your work back if you happen to crash?
Yeah, because it's writing to disk at all time, right?
I'm not sure. I'm not sure how much it caches to disk versus how much it caches in RAM. I've never worked on it, so I don't know exactly how it operates.
Yeah, we'll definitely be providing you a lot more information on all these features coming in our release notes, which will be soon. We don't have an exact date yet when 4.23 will be out, but it is very soon. As of right now, you can check out Preview 6. That is available on the launcher as well as GitHub. And remember, if you want to try out our new Chaos Physics engine, you should head over to GitHub. I wrote up a little section on the forums of how you can actually get started, because there is a line you need to change in the editor target file. With that said, I think I want to thank Marcus for coming on, taking some time out of his day, as well as Michael, who is in Chicago, if anyone was curious where he's calling in from. Beautiful, very large city that I've had the fortune of visiting several times. I'm sure Michael likes it over there, and that's why that's where he spends his time. With that said, as always, if you do what we do, which is streaming on Twitch, make sure that you add the category of Unreal Engine so that we can tune in. I was watching quite a couple of the people who were streaming the game jams, and it's always exciting to go in and see what they're working on. If you happen to have a meetup group that we're also referred to as user groups in your city, go ahead and go to unrealengine.com/user groups. I really should get that link down, but I'm sure it's in my notes somewhere. I don't visit it a lot because it's in my favorites, so I just click a button. But you should go check them out. It's always exciting to share your projects with the rest of the developers that are local to you. And if you don't happen to have a meetup, you can go ahead and contact us at community@unrealengine.com. And if you're excited or interested in hosting and organizing one of these, let us know, and we will get started for you with a bit of information on what it entails, what it involves, how you can possibly put all of that together, and we will make sure to help you out. Other than that, make sure you subscribe on our channels and to sign up for all the news that's coming out, which will certainly in just a bit will be some of the blog posts coming out around 4.23 release, and all the other cool tech blogs and various things that we are releasing through our channels. And I think with that said, anything else that we should mention before we end? I don't know, Marcus, do you have anything?
I think we covered a lot of ground.
I think so too. And Michael saying goodbye from Chicago, and we will see you all next week.
All right.
Bye, everyone.
Thanks, everyone.